What is up, guys? A few nights ago I rode my bike to Walmart to pick up an iTunes gift card because the new Brawl Stars Battle Pass had just come out. And after stepping outside with the gift card in my hand, I realized my bike had vanished. Now this made no sense to me. I thought that I had ended bike theft years ago, but I guess the local thieves must have changed their thief methods. And then it struck me. I have to end bike theft for good. To do this, I had to get into the mind of the thief. So I stole a bunch of protein shakes from Target and then got in trouble where I learned something invaluable: tasers and penetration. So me and Nick got to work. I started off with the easiest part, the tasers. I began by connecting this high voltage module thing that I found on Amazon to a relay and then an Arduino so that I could turn it on and off with the press of a button. According to this website right here, these things are capable of producing like 20,000 volts, which is definitely a lie. That's why I'm gonna touch it to find out. No, I'm just kidding. Instead of touching it, I moved on to the penetrator. After months of hard thinking, I came up with a design. The plan was to basically make a spring-loaded metal rod that would go off whenever it detected a thief, similar to the spring traps that are in my base right now. I bought some metal, some springs, a servo motor, and began welding. Speaking of welding, shout out to VEVOR, today's sponsor, for giving me a free welder, a metal forge, and a plasma cutter. Now sadly, I never used the other two, but I definitely will in the future. You guys are legends. After cutting, welding, coating, and assembling everything, the bike seat was done. Or so I thought. Me and Nick ended up testing it on a variety of different objects. Nick even voluntarily tested it on himself. Now, as I was editing the video, something just didn't sit right with me. The bike seat I had made was not good. It was blatantly obvious that the bike had a booby trap on it. The rod would randomly come out of the seat even if you were the one riding it. And honestly, the one I made 3 years ago was maybe a little bit better than the one I had just made. And I couldn't come back from a 2-year slumber just to release trash on my loyal fans. Despite Nick begging me not to, I deleted the whole entire video, never to be seen again, and went back to the drawing board. I began thinking again, this time for another month, and after coming up with nothing, it hit me. A solenoid. This would be perfect. I could make it go back and forth whenever I wanted to. It looked cool, and I had no idea how to build one or even how they worked at all. So I started experimenting. So I'm down here with Nick right now, and we're gonna test that. My guess is it's either gonna go that way, or what I want to happen is for it to center in the middle. This is much more scary. I just gotta do it. I made several different versions, like this long one, this short one, and then this kind of good one, but nothing seemed strong enough. I had no idea how the basics like Ohm's law worked, or how to even make a semi-decent magnetic field at all. So I gave up and went back to college for a whole year. And then I came back with more knowledge. And here's where we are now. When current flows through a loop of wire, a small magnetic field is created. Now let's say instead of 5 loops, you were to have like 100 loops or something. This would create a much stronger magnetic field, probably strong enough to move a tiny metal rod. Now here's a really bad one that Nick unfortunately made.
I didn't make that.
This is basically just some normal basic wire wrapped around a PVC pipe. And now when we hook it up to the power supply over here, it should hopefully be strong enough to shoot this tiny little metal screw out of it. All right, so I'm gonna tap it. Oh, see? Now, unfortunately, this coil right there is very inefficient. You're probably wondering, why is it so inefficient? Well, here's why. This big equation on screen represents the force that a solenoid exerts on a steel rod. We've got the permeabilities of the air in the rod, the number of turns, the cross-sectional area of the core, the coil length, the current, and like a bunch of other stuff, which I'll throw on screen right now, just in case you're interested. For a multi-layered solenoid, which is what we're gonna need, each layer of wire sits kind of on top of each other, weakening the magnetic field. Now to simplify things, we could just express this as a summation. We can clearly tell that in order to maximize the magnetic field, our design has to have the smallest possible rod to edge gap, a thinly coated, tightly wound, low resistance wire to allow for a maximum current flow at a set voltage, a highly permeable rod material, and we're gonna have to hope that I can actually build this thing without it breaking. I loaded up Tinkercad, designed and printed this thing, and began winding 200 feet of magnet wire by hand. Literally right as I was down to my last foot of wire, the worst possible thing happened. The little center plastic piece snapped. At that point, I decided it might be time to delete the video. When miraculously, I came across this young man's video on drill-powered coil winding. So I built his device, which should hopefully put pressure on the center, preventing it from breaking, reprinted everything, and then began drilling. After only about like 2 hours, we had our brand new coil all done and not broken. All right, I'm in the lab right now, and we're gonna test this out. We got our metal rod, the metal wood hybrid rod that I just made back there. So yeah, let's power this up. Whoa! Oh, no! That's not good. I might have damaged the epoxy in there. Yeah, we're gonna test it out on this prized piece of glass right here. Let's do it. That was actually pretty good. What would you rate the damage, 1 to 10?
Yeah, good. 7.
7? I'll take it. Now all that's left to do is to take our coil, ramp up the voltage a bunch, make it battery powered and able to be controlled with a microcontroller. As of right now, I go back to school in like 3 weeks, which means tonight I have to try to design and order all of the parts, which leaves us with one final option: reunite with the oldest member of the Random Creation Science team, Nerf Nerd. No way, is that him?
What are you doing here?
All right, Nerf Nerd, do you have any idea what to do as the lead member of the science team? Oh, thank you. Here you go. All right, so I think I may have actually figured it out. We get a 220 volt high capacitance capacitor, charge it with a boost converter that can be toggled on and off with this little blue relay. And then connected to that capacitor, we put the solenoid parallel with a diode to take care of the reverse voltage spike when the magnetic field breaks down. Now this will be connected to the drain of the insulated gate bipolar transistor, or the IGBT. To enable this thing to be controlled with our Arduino, I got this little gate driver thing, which should help drive the gate. After sketching everything, ordering all the parts, wiring, and programming the timings of everything in, it was time to test it. I did a few things off camera, like mount all the stuff on there. I added a few more components that I forgot while I was editing in the voiceover, which that's my bad. So the code we're gonna load up right now is just gonna test the gate driver. And if that doesn't work, then we are screwed. If we get 15 volts, that's a good sign. Guys, I think we have our first success. It says 15 on there. I think honestly, I'm just gonna go for it. We're gonna charge the capacitor up, press the button, and see if it works. It did not work. After multiple failed attempts, I sent Nick home and began troubleshooting. After swapping out the chip, I kept getting a gate voltage of 2.6, which made absolutely no sense to me, since we were literally measuring like 15.1 like an hour ago. At this point, it was already 1 a.m. I was ready to go to bed when all of a sudden it hit me. We were using a 47,000 ohm resistor instead of a 47 ohm one, which as you'd imagine is kind of a big deal. I rushed downstairs, replaced it, charged the capacitor up to a safe testing voltage, and it worked. Oh my god!
No, don't.
We got the bike seat all done. So yeah, let me give you guys a quick rundown before we test it out. So we've got the on and off switch in the back here. We've got the button to charge the capacitor. We've got the trigger button right here. It's kind of like a little pressure plate thing. So when it detects a thief sits on it, it'll cue the shooting sequence. I mean, that's basically it. That's all you guys gotta know. I did want to film this thing outside, but it's unfortunately 4 a.m. in the morning right now. So we're just gonna do it in the garage. First test, we just gotta see if this thing actually works. We're gonna charge it. I'm gonna press this and it should shoot out. I'm surprised that this thing actually works. I got this stainless steel metal safety guard that I just made. We're gonna put this over all the contraptions when I do the testing on our objects. Let's start off with a little glass. 3, 2, 1. Oh my god, that like exploded. I did not think about the cleanup after this.
It's too late now.
The second object we're gonna test is this plate. I'm actually gonna be kind of sad to break this one because this is a very nice plate. It's very thick also, so I'm kind of having my doubts honestly about it, but let's give it a try, give it a go. 3, 2, 1. Dude, that just took a chunk out of it. Look at that. Woo! I'm surprised that this thing is actually working because usually every video I make sort of fails. Stage 3, this disgusting white plate. Now this one, I don't know if this one's gonna shatter because, watch this.
I didn't expect you to do that.
Well, moving on to the almost human-like simulation object. The yellow, you know what this is called?
It's honeydew.
Honeydew? All right. 3, 2, 1. Oh, that like just pierced through it. Look at it, it's dripping its seed on there. That's disgusting. All right, we're back after a little technical difficulty. I think I just had to let it cool down because it was getting a little bit hot. And I switched into my lucky Fortnite shoes. For this final watermelon test, I put a little spike down there just for some added funness. That just penetrated it. Look at that. Thank you guys so much for watching. Be sure to like and subscribe, and I'll see you in 2 more years.